So first up, I'm proud to introduce James Rowland. James is part of a team with Mark Walter and Matthew O'Kelly that was the winner of our Equipment and Appliances campaign. And James is an engineer at Priority Designs, an industrial design and engineering consulting firm in Columbus, Ohio. His work shifts between electrical and mechanical design and testing for various product development programs. He's also currently consulting for the Ohio State University Office of Energy and Environment by advising and supporting the research activities associated with the Ohio State Solar Decathlon entry Encore, which is a program that we funded ERE, so we're excited to see you're involved in that. His research is in control systems focused on the application of optimal control for residential building energy management. In particular, he led the testing and optimization of the alpha prototype of Energy Hawk, which is a system producing integrated desiccant-assisted heat pumps for residential heating, air conditioning, ventilation, and water heating. The idea that they have is a hybrid air water conditioner, which exploits synergies between conditioning indoor air, dehumidification, ventilation, and hot water heating to significantly reduce energy expenditures associated with those processes. So James, over to you.
Good morning. Thank you, David, for the introduction. And yes, I am here on behalf of my graduate advisor, Dr. Mark Walter, and my predecessor, Matthew O'Kelly. And our idea is Energy Hawk. And what is Energy Hawk? Well, it's an integrated heat pump that uses a couple techniques to save energy. The first is it uses a solid desiccant wheel to do separate, sensible, and latent cooling. The other side of it is that we make use of the waste heat from the vapor compression cycle in cooling mode. So the way that we came up with this idea really started in our solar decathlon experiences. We kind of saw that the market was changing, but the current technology was really struggling to keep up with it. In 2011, we entered into we participated in the solar decathlon competition, and this is our entry Encore. If you're not familiar with solar decathlon, the purpose, or one of the big purposes, is to have universities and other partners compete to build net zero houses in terms of energy consumption and energy production. And one of the ways that is used widely in order to achieve that goal is to add a lot of insulation to the house and seal the building envelope very tightly. We started to run simulations on this house to determine what type of HVAC equipment would be required to maintain the comfort zone. And we started seeing that even in mildly mixed climates, houses built to these standards would experience high humidity or high moisture events throughout the cooling season, roughly 10 to 20% of the time. Basically, the vapor compression systems and the ventilation systems that were available at the time were not able to handle that indoor environment. So what we tried in 2011 in the solar decathlon house was using solid desiccant wheels to do separate, sensible, and latent cooling. In 2011, or in that house, we used that desiccant wheel to dry the return air from inside of the house, as well as fully dry ventilation air coming into the house. And then we used solar thermal hot air to regenerate the desiccant. So we took our learnings and our experiences from that house, and we entered into a couple of Department of Energy competitions, which allowed us to build 2 prototypes here, which took that idea of separate, sensible, and latent cooling, as well as waste heat recapture, and build it into a single package that could be a complete mechanical system for your passive house. So on the left, you see our first proof of concept prototype. It was very large, very big, but we were still able to package everything into a single unit. And we were trying to explore the limitations and the challenges that we would incur in trying to packaging that in a small piece. On the right-hand side, you see the prototype from the following year, and we were able to consolidate some of that size, as well as make some gains in our efficiency. Finally, last year, we built this, our beta prototype, and what you see are three main components. On the far right is our air handler, which is basically a modified standard air handler off of a mini split unit, a modified water tank, and then an outdoor heat exchanger. So the way our system works, you can see the top colored line. We draw in air from the outside, dry it using the desiccant wheel, and then following that desiccant wheel, the air experiences an increase in the sensible temperature. We reject that to the exhaust stream, and then we combine it with return air and cool it before we introduce it back into the house. The lower half of this diagram is our vapor compression system, and you can see that we use the heat from the cooling mode to either regenerate the desiccant wheel or produce domestic hot water. And our big accomplishment with that beta prototype was to combine all of these elements that treat the air into a single unit that was competitive in terms of size on the market. So what's next for us with Energy Hawk and our technology? Well, over the past 3 years, we've gathered together $155,000 in grants and awards through participating through other Department of Energy competitions, primarily the Max Tech and Beyond competition, which was organized by Lawrence Berkeley National Lab. And we also secured significant funding from the Ohio Third Frontier Venture Fund. That allowed us to fund my master's degree and another master's degree. Also helped us piece together some business plans and try to see what we would need to do in order to launch this thing actually out into the market. It's also enabled us to file a utility patent on the combination of technologies. And where we're at now is we have a beta prototype that is actually a complete replacement for the mechanical systems of a high-efficiency home. So where are we going forward, or where are we going now? We see the market is growing, and we expect it to continue to grow. One of the big challenges in order for us to get actually into that market would be that we need to conduct standardized testing and certification procedures on our beta prototype. We've done significant in-house testing using environmental chambers that we constructed ourselves, but they're not exactly up to ASHRAE standards, and we're not exactly able to test according to ASHRAE standard 206. Throughout the past 3 years, we've tried to take any opportunity that we can to demonstrate the technology to industry, and we're always looking to license or move forward with a cooperative research and development agreement. So this is my contact information. We also have a booth just kind of outside that last door, and I encourage anyone, if you have any questions, to please come and talk with me. So, thank you.